You can actually create functional, physical web fluid at home. The process is safe, accessible, and uses common materials that require no specialized chemical knowledge to handle. To begin, gather these items: white PVA glue, room temperature water, a small mixing cup, a wooden toothpick, and a squeeze bottle with a narrow, pointed nozzle. Achieving thin, clean strands depends on the precision of your mixture and the mechanical force used during the application. Step 1 is setting up the workspace. Clear a flat, stabilized surface, and, if you're documenting this, mount your camera on a tripod. We need absolute stillness to accurately observe the texture of our mixture. This diagram outlines our starting point. The structural integrity of the web relies on a strict ratio, exactly 2 parts white glue to 1 part room temperature water. Do not mix a massive batch right away. Start with a very small quantity, maybe a few tablespoons, so you can master control over that baseline ratio. Take your wooden stirrer and begin blending the 2 components together. Keep stirring until the fluid looks like smooth, glossy paint. You want a uniform texture with 0 unmixed lumps left. Locking in that perfectly smooth consistency is the non-negotiable prerequisite before we can move on to structural testing. Now that we have our base mixture, we need to diagnose its viscosity using the strand test. Dip your wooden toothpick deep into the fluid mixture, then pull it straight up at a slow, deliberate speed. A successful mix will produce a single, highly elastic thread that remains unbroken as it stretches upward. This graphic illustrates failure states compared to a correct mix on the right. If your strand snaps instantly, the mix is too watery. Fix this by adding 1 drop of glue, stirring, and retesting. Conversely, if the fluid lifts in a heavy, stubborn glob that refuses to stretch, your mix is too thick. To fix this, add exactly 1 drop of water to thin it into a sleek line. Expect to run through this loop several times. You will adjust with single drops, stir, and pull a new test strand. Keep in mind that slight variations in your room's temperature or humidity will directly impact these micro adjustments. The moment you pull a clean, unbroken stretch, halt all adjustments immediately. The strand test offers a clear benchmark for success, replacing guesswork with a repeatable way to check the fluid. With the fluid calibrated, carefully pour your completed batch into the squeeze bottle. The narrow, precise nozzle on this bottle is essential. It acts as a mechanical choke point, forcing the liquid out as thin web threads. Before you fire, check your environment. Because these threads are so light, a mild draft can tear them apart. This layout shows the optimal firing range. For the fluid to travel and stick properly, position the nozzle exactly 20 to 30 centimeters away from the target surface. When you fire, use rapid, short bursts of pressure with your hand. Do not use one long, continuous squeeze. Combining the compression of that nozzle with precise short burst pressure effectively simulates how a pressurized mechanical shooter functions. Once the wet strands hit the target, they only need a few minutes to dry and lock their pattern onto the surface. Because we used standard PVA glue and water, the final product is fully washable and can be removed from surfaces without leaving a permanent mark. Now that you have the baseline technique, try swapping in different nozzle diameters on future batches to experiment with the thickness and spread of the fluid. Following these ratios and testing your results allows you to turn basic glue and water into a predictable, functional prop.